here basically starts with the first question. What happens to be my first question? First question in here is for 1 mark. We are discussing the CBSE pattern question exercises for probability class 12th. First question for 1 mark is giving us 2 events, event A and event B, such that probability of occurrence of event A is half. Occurrence of event B has probability 7 by 12 and probability of not A or not B is given to be 1 by 4. State whether A and B are independent or not. When do you say 2 events are independent? When occurrence or happening of one event does not affect the probability of occurrence or non-occurrence of the other event. In that situation, what happens is, suppose A and B are 2 events, probability of A when B has already happened is going to be equal to probability of A itself, because happening or not happening of B is absolutely not affecting the probability of happening of A. So whether B has happened or not happened, probability of A when B has happened or probability of A when B has not happened remains the same. Similarly, probability of B by A happens to be equal to probability of B. That means probability of happening of B when A has already happened or probability of happening of B when A has not happened, they are the same, because happening or not happening of A does not affect the probability of happening of B. Because of these facts related to 2 events being independent, I get probability of A intersection B to be equal to probability of A into probability of B, provided A and B are independent. That means if I have to show that A and B are independent, I have to come to the conclusion regarding A and B that whatever is the probability of their intersection, that is equal to the product of their individual probabilities. If these 2 probabilities come out to be equal, I get that A and B are independent, and if they happen to be unequal, I say that A and B are not independent. So let's begin with watching out the conclusion regarding the independence of the 2 events A and B. Probability of A is this, B is this, probability of not A or not B is 1 by 4. How do you write that? Not A means A bar, or means union, not B means B bar. Not A or not B. This is given to be 1 by 4. By the De Morgan's law, we know that A complement union B complement is A intersection B whole complement. Whatever was the meaning of complement in the chapter sets, same is the meaning of the bar over here upon the alphabets A and B. So probability of A bar union B bar is probability of A intersection B whole bar, just by De Morgan's law. This is 1 by 4. What is this? This is probability of not happening of the event A intersection B. Probability of not happening of an event is 1 minus probability of happening of that event. That is 1 by 4, and therefore I get 1 minus 1 by 4 to be probability of A intersection B, which is 3 by 4. Fine. One thing we've got. What about probability of A into probability of B? Probability of A is given to be half. Probability of B is 7 by 12. So you get 7 by 24 as the product of the individual probabilities of A and B, which is absolutely not equal to 3 by 4, which is probability of simultaneous occurrence of A and B. And thus, A and B fail to be independent events. Is it understood? They are absolutely not independent, because probability of simultaneous occurrence of A and B is 3 by 4, but the product of their individual probabilities is 7 by 24, which is unequal. Moving to the next question, we have for 2 marks coming that a couple has 2 children. Find the probability that both are boys if it is known that the older child is a boy. Okay, so if a couple has 2 children and we are wanting to find out the probability that both the children are boys, given that older child is a boy, how do you start your question with? Sample space, what would that be? 2 children are born. It can happen that first child is a boy, second is also a boy, okay? Or it can happen that first is a boy, second is a girl. Or it can happen that first is a girl, second is a boy, or it can happen first is a girl, second is a girl. So you know in what sense have I written B1, B2, G1, G2. B1 means first child is a boy, G2 means second child is a girl, B2 means second child is a boy, G1 means first child is a girl. Okay? This is what happens to be the sample space corresponding to 2 children being born to a couple. Now here it is saying, find the probability that both are boys. Suppose I say my event A is that both the children are boys. And I am defining another event that older child is a boy. Now let's see what happens to be the elementary events favorable to these events. Both are boys. This is the elementary event favorable to event A. Fine. Both the children are boys. Apart from this, is there any other elementary event favorable to event A? No. In all the rest of the elementary events, there is at least one girl definitely being born to the couple. I am interested in the elementary event which supports or favors that both the children born are boys. So only this elementary event does that. So this will be a singleton set consisting of B1, B2 elementary event. Next I have older child is a boy. You can see first child is a boy, second is a boy. First is a boy, second is a girl. First is a girl, second is a boy, first is a girl, second is a girl. Obviously the child born first would be older. I am given that the older child is a boy. That means only this and this I can select as the elementary events favorable to my event B, because only in these two cases the boy is being born before the next child. So older child is definitely a boy. So I have B1, B2 and B1, G2. I am being asked what is the probability that both are boys when it is known that older child is a boy. Isn't this beautiful? How actually a practical scenario gets boiled down to a conditional probability question. What is the probability that both the children are boys when you know that older child is a boy? What is the formula? This is probability of A intersection B upon probability of B. Or I can also say this is also equal to number of elements in A intersection B upon number of elements in B. When you divide the numerator and denominator by number of elements in the sample space, you obtain this as your very formula for P of A by B. How many elements are there in A intersection B? If you talk about this is A, this is B, then clearly A intersection B consists of just B1, B2, isn't it? Only one element is common. So number of elements in A intersection B is 1. Number of elements in B, event B has 2. So 1 by 2 happens to be the probability of both the children being boys when you know that the older child is a boy. Is it clear? Easy enough? Next question, let's see what is it. The probability that a teacher will give an unannounced test during any class meeting is 1 by 5. If a student is absent twice, what is the probability that he will miss at least one test? Now let's say that E1 is the event that student misses the first test. Student misses the first test. And let's say E2 is the event that student, the same student, misses the second test because he's absent twice. Now see, teacher is giving an unannounced test during any class is holding probability 1 by 5. If a student is absent twice in that class, then what is the probability that he misses the first test? One day he is absent, that day he can miss a test only if the teacher decides to take the test on that day. The probability that the teacher is going to take the test on that day is 1 by 5. Same is the probability that the student will miss the test on that day. Obviously, if he is absent on a certain day and the teacher is not taking a test on that day, how can he miss the test? He can miss a test on a particular day when he is absent only when the teacher decides to take the test on that day, and that holds probability 1 by 5 that she is going to take a test on a particular day. If that is 1 by 5, then that is the same probability of the student missing the first test. So, probability of happening of event E1 is 1 by 5. Similarly, he can miss the second test only when the teacher decides to take the second test on the day when he is absent. Fine? And a teacher holds probability 1 by 5 of taking that unannounced test. So, the student missing that test is again 1 by 5. So, probability of event E2 is also 1 by 5. Tell me one thing, are E1 and E2 independent events or not independent events? If a student is missing the first test on a certain day, does it hold any contribution towards the probability of the student, same student missing the second test on some other day? Of course, these two are unaffected events. If he has missed the first test on a certain day, how is that going to be affecting the probability that he's going to miss a second test or vice versa? Clearly, E1 and E2 are independent events. They are independent events. If that's the scenario, what is the probability of E1 intersection E2? You all know this is equal to probability of E1 into probability of E2. Fine. This is something you need to keep in mind because they are independent events. I am being asked what is the probability that he will miss at least one test. He is missing the first test is event E1, he is missing the second test is event E2, so he will miss at least one test, means he will either miss the first test or he misses the second test. So either E1 occurs or E2 occurs is the event whose probability needs to be computed, that is being asked in the question. Okay, so you need to correctly decode what is that event whose probability the question is indirectly or in statement form asking you to compute. What is this? This is probability of E1 plus probability of E2 minus probability of E1 intersection E2. Probability of E1 is 1 by 5, this is again 1 by 5. What is this? This is probability of E1 into probability of E2, which is 1 by 5 into 1 by 5. This is 2 by 5 minus 1 by 25. This happens to be 9 by 25. If you don't like it this way, you can also compute this in other fashion. Probability of E1 union E2 is 1 minus probability of not happening of E1 union E2, right? What is this? By De Morgan's law, this is probability of E1 bar intersection E2 bar. Now you know we have done this result in our theory lecture that if E1 and E2 are two independent events, then their bars are also independent events. So clearly this is equal to 1 minus probability of E1 bar into probability of E2 bar. Probability of E1 is 1 by 5, so probability of not happening of E1 is 1 minus 1 by 5. Probability of happening of E2 is 1 by 5, so probability of not happening of E2 is 1 minus 1 by 5. This again is going to give you 9 by 25. Is it clear? That's how you attempt this question. Okay? Moving to the next, we have for 4 marks. Probability of A is given, B is given, A intersection B is given. Find probability of A bar by B bar and probability of B bar by A bar. Let's try to do that. Okay, so probability of A bar by B bar. Just apply the definition of condition probability. This is equal to probability of A bar intersection B bar upon probability of B bar, right? What is this? By De Morgan's law, A union B whole bar upon probability of B bar. Not happening of event A union B, not happening of event B. What are their probabilities? 1 minus probability of happening of the respective events. This is 1 minus probability of happening of A union B, 1 minus probability of happening of event B. In here, this is probability of A plus probability of B minus probability of A intersection B, and this is 1 minus probability of B. What is this? Probability of A is given to be 3 by 8. Probability of B is 1 by 2. So you have 3 by 8 plus 1 by 2 minus 1 by 4 whole upon 1 minus probability of B is 1 by 2. What is this? LCM will be 8. You have 3 plus 4, 7. 7 minus 2 is 5. So you have 1 minus 5 by 8 upon 1 minus 1 by 2 is 1 by 2. This is 3 by 8 upon 1 by 2. Right? Because it is 8 minus 5, 3 by 8 upon 1 by 2. So this is 3 by 8 into 2, which is 3 by 4. Fine. This happens to be probability of A bar by B bar. Exactly in a similar fashion, you can compute probability of B bar by A bar. What would that be? This is B bar this is A bar. It is again B bar intersection A bar, which is same as A bar intersection B bar's probability upon probability of A bar. This is A union B whole bar upon probability of A bar. This is the same. Just A over here. This is the same. Just A over here. This is the same. Probability of happening of event A is 3 by 8. That's the only difference. This is the same. 8 minus 3 is 5. So you get 5 by 8. Right? 8 minus 3 is 5. 5 by 8. This gives you 3 by 8 upon 5 by 8. What would this be equal to? 3 by 8 divided by 5 by 8 is 3 by 8 multiplied by 8 by 5. So this just gives you 3 by 5 as your answer. Understood? Moving to the next, we have two integers are selected at random from the integers 1 to 11. If the sum is even, find the probability that both the numbers are odd. It's a very interesting question. Let's try to decode the solution corresponding to this. Now when I write the integers, let me write 8, 9, 10 and 11. Integers 1 to 11, if you can see, 2, 4, 6, 8 and 10. I have 5 even integers and 1, 3, 5, 7, 9, 11. I have 6 odd integers. I am choosing 2 integers out of these integers from 1 to 11. If the sum is even, find the probability that both the numbers are odd. Suppose I say event A is both selected numbers are odd. Both selected numbers are odd. In how many ways? In how many ways, or rather than that, I should say, what are the chances of occurrence of this event? What are the chances that 2 odd numbers will be selected among these 11 numbers? So total number of ways in which you can select 2 numbers out of these 11 numbers is 11C2. Out of these ways of selecting 2 numbers out of these 1 to 11 numbers, how many are the ways in which you can have both of them as odd numbers? Total odd numbers in here are 6. Out of 6, you can choose any 2 in 6C2 ways. This is the favorable number of ways, this is total number of ways. Total number of ways of selecting 2 integers out of these integers from 1 to 11. That's the total number of ways. And what are the favorable ways? That means number of ways in which both the integers chosen are odd, that is 6C2. Fine. Next you have, I am defining event B as sum of the 2 numbers is even. Now you know that if you have integers from 1 to 11, fine, if you have integers from 1 to 11, or you have integers basically, when are you going to get sum as an even integer? Either you add both the odd integers with each other, or you add 2 even integers with each other. Only these are the 2 situations which can land you up getting the sum as even. When 2 odd integers are added or when 2 even integers are added, only then you get sum to be even. When 1 odd and 1 even is added with each other, you don't get even integer. So sum is even. What is the probability of occurrence of event B? Again, total number of ways of choosing 2 integers out of these laid down integers from 1 to 11, it is 11C2. Fine. How many are the ways in which the 2 integers that you are going to select from these 11 integers can give you even sum? Either, now please understand the situation very nicely, you can have sum of the 2 chosen integers as an even number provided both the integers chosen are even or both the integers chosen are odd. Please understand, both the integers chosen are even or both the integers chosen are odd. If you can remember the permutation and combinations addition principle, then you can very easily connect that I will be adding the individual probabilities of both the integers chosen being even and both the integers chosen being odd, because OR word comes in the addition principle leading to plus sign. And therefore, sum can be even if out of 11 both the integers chosen are even. Even integers can be chosen, 2 even integers can be chosen in 5C2 ways, because in total there are 5 even integers in here from 1 to 11. Or you can choose 2 integers both being odd out of the 6 available odd integers. So sum can be even in 5C2 plus 6C2 ways. That is the number of ways in which 2 even integers can be chosen plus number of ways in which 2 odd integers can be chosen. Fine. This happens to be probability of occurrence of event B. Question is, find the probability that both the numbers are odd if it is given that the sum is even. So what is the probability of A by B? What is the probability that both the numbers are odd if it is known to you that sum is even? This is probability of A intersection B upon probability of B. What is probability of A intersection B? A intersection B means, what is the probability that the sum of the two numbers chosen is an even number when both the numbers are odd numbers? So A intersection B, actually it is trying to say that the two numbers chosen are odd and their sum is even. Now if two numbers chosen are odd, then obviously their sum is even. So rather than saying two numbers chosen are odd such that their sum is even, I am just going to say both numbers chosen are odd. Two odd numbers can be selected out of these 11 integers in how many ways? Total number of ways of selecting two numbers is 11C2. Out of that, two odd integers can be chosen in 6C2 ways. So this is the probability of A intersection B. It is 6C2 upon 11C2 upon probability of event B, which is 5C2 plus 6C2 upon 11C2. This cancels out. You have 6C2, which is what? 6 factorial upon 2 factorial into 4 factorial, which is what? 30 upon 2, that is 15. 5C2, you all know 5C2. 5C2 is 5 factorial upon 2 factorial into 5 minus 2, that is 3 factorial. This gives you 10. Plus 6C2 is again 15. So this is 15 by 25. Which is 3 by 5. That happens to be your respective probability. Moving to the next, we have find the mean of this binomial distribution. Now clearly you should be aware that B 4, 1 by 3 is trying to give you what all information. This is sufficient information to actually lay down the entire binomial distribution of the binomial variate capital X and hence compute the mean. How? Because when you have B 4, 1 by 3, this implies n, that is number of Bernoulli trials, is given to you as 4 and the probability of success in each trial is given to you as 1 by 3. Therefore, probability of failure, that is probability of not success, will be 1 minus 1 by 3, that is 2 by 3. So I am clearly saying that let capital X be the binomial variate with binomial distribution having parameters. Now the parameters, you all know, we've discussed it a lot in the theory lecture. There are just two parameters to be taken into account which give you the entire information about binomial distribution and then further anything that you require. Parameters are n and p. N is 4 and p is 1 by 3. If n is 4, number of trials are 4, so how many successes can you obtain? Either 0, 1, 2, 3 or max 4. So x can take values. X is actually representing the number of successes. So x can take values 0, 1, 2, 3 and 4. Fine. So we are in a position to actually lay down our entire binomial distribution. So because this is going to actually consist of large values, you can draw it in a column format. Let's not draw it in this row format. So my x is going to take values as 0, 1, 2, 3 and 4. What are the respective probabilities? You know that probability of R successes occurring in n trials is given by NCR p to the power r q to the power n minus r, which is what? N is 4, 4CR, p is 1 by 3, to the power r, q is 2 by 3, to the power n minus r. R successes means 0, 1, 2, 3, 4. Because maximum there are 4 trials. So in 4 trials you can have these many successes. So probability of x equals 0 will be what? NC0, 4C0, p to the power 0, that means 1 by 3 to the power 0, which is 1, 2 by 3 to the power 4 minus 0. What is probability of a capital X equals 1? It is 4C1, 1 by 3 to the power 1, 2 by 3 to the power 4 minus 1. Here it is 4C2, 1 by 3 to the power 2, 2 by 3 to the power 4 minus 2, that is 2. Here it is 4C3, 1 by 3 to the power 3, 2 by 3 to the power 4 minus 3, that is 1. And here it is 4C4, 1 by 3 to the power 4, 2 by 3 to the power 4 minus 4, that is 2 by 3 to the power 0, which is 1. This happens to be your binomial distribution completely. You are not being asked the binomial distribution, you want the mean of the binomial distribution. What is the formula for mean? Mean is nothing but summation pixi, I running from 1 to n. How many ever values are there which capital X is assuming. So here pi's I already have, xi's I have, I will just be multiplying. So x into px, or you can write xi into pi, whatever terminology you wish to keep. This happens to give you 0, 0 into this is 0, 1 into this is same as 4c1 into 1 by 3, 2 by 3 to the power 3, then it is 2 into this, 2 multiplied by 4c2, 1 by 3 to the power 2, 2 by 3 to the power 4 minus 2, that is 2. Then you have 3 multiplied by 4c3, 1 by 3 to the power 3, 2 by 3 to the power 1. And then you have 4 into 4c4, 1 by 3 to the power 4, 2 by 3 to the power 0, which is 1. When you add all this up, you get your mean. So your mean is summation of xpx, right? Summation of xpx, which is going to come out to be 108 by 81 when you add all these up. Or you can say this is your xi, you can say this is your pi, you can say this is pi into xi, and therefore you can say this is xi into pi, I running from 1, 2, 3, 4, 5, so 1 to 5. Fine, because there are 5 values which x is assuming. This is x1, x2, x3, x4, x5, p1, p2, p3, p4, p5. So this comes out to be 108 by 81. 27 into 3 is 81, 27 into 4 is 108. So 4 by 3 happens to be the mean. Is it clear? Since mean is summation pi xi, I running from 1 to 5 for this question. Clear? Moving to the next, we have a man is known to speak truth 3 out of 4 times. He throws a die and reports that it is a 6. Find the probability that it is actually a 6. That means find the probability that the man is speaking the truth. Okay? Let's say event E1 is that 6 occurs, and event E2 is that 6 does not occur. We are just interested in one outcome. And event A is that man reports it's a 6. I am interested in knowing, find the probability that it is a 6 when the man has reported that it is a 6. Find the probability that it is a 6 when the man has reported that it is a 6. What is this? Can you recall something? A majorly important theorem to be acting in here, that is my Bayes theorem. Isn't it? Entire hypothesis is supporting Bayes theorem. So probability of E1 by A would be what? Probability of E1 into probability of A by E1 upon probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2. Reverse probability is what we are interested in finding. What is the probability that 6 occurs when the man has declared that it is a 6? Okay. Finding probability of A by E1 is fine, but probability of E1 by A requires Bayes' theorem. Reverse probability, we have done it very nicely in the theory. What is this? What is probability of E1? Probability that 6 occurs when he has thrown a die. When you throw a die, probability of occurrence of 6 is 1 by 6, right? So probability of E2 is probability of not happening of E1, not happening a 6, not occurring of 6 is 1 minus probability of happening of E1, which is 5 by 6. What is probability of A by E1? Try to understand this event very nicely. Probability that the man reports it's a 6 when 6 has already occurred. Probability that man reports it's a 6 when 6 has occurred. When 6 has occurred and man is reporting it's a 6, that means what is the probability that man is speaking the truth? Isn't it? It is probability of man speaking the truth. That means if 6 has occurred, what is his chances that he is going to say that 6 has occurred? That means what are the chances that he will speak truth? That is given to you as 3 by 4. It's given to you that the man speaks truth 3 out of 4 times, so probability of him speaking the truth is 3 by 4. What is the probability of A by E2? That means what is the probability that man reports it's a 6 when 6 has not occurred? When 6 has not occurred but the man is going and reporting it's a 6, that means what are the chances that he speaks false? Probability that man doesn't speak truth. Because 6 is occurring or 6 is not occurring and he is going and reporting it's a 6. That means he is not reporting what is true, he is reporting what is false. That means what is the probability that man is not speaking the truth? It's 1 minus probability that he is speaking the truth, which is 1 by 4. And now it's very easy. Probability of E1 is 1 by 6. Probability of A by E1 is 3 by 4. Again it is 1 by 6 into 3 by 4 plus probability of E2 is 5 by 6 into probability of A by E2 is 1 by 4. What is this? 3 by 24 whole upon again 3 by 24 plus 5 by 24. This gives you 3 by 8 as your answer. Clear? Let's talk about the next question we have for 6 marks. Coming up next is there are 2 bags. One contains 3 black and 4 white balls. Let's just try to draw the scenario so that we don't get lost in the question. That's always advisable. The moment you see a question of large length, try to diagrammatically present as much as you can. So you have, suppose this is your bag 1, 3 black, 4 white balls. So black, black, black. 4 white, 1, 2, 3, 4, white, 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 white. This is bag 1. And say this is another bag, 4 black and 3 white. So black, 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 3 white, 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 white. This is bag 2. Okay. Now it's said that a fair die is cast if the face 1 or 3 turns up, a ball is taken from the first bag. So event E1 is 1 or 3 turns up when you toss the die. The moment event E1 occurs, bag 1 is chosen. And event E2 is, let's see, a ball is taken from the first bag, and if any other face turns up, the ball is chosen from the second bag. So 2 or 4 or 5 or 6 turns up, that means anything else apart from 1 and 3 turns up, then bag 2 is selected. Fine. What is the probability of occurrence of event E1? Out of the 6 outcomes that you get when you roll a die, these two can occur in 2 by 6 ways. They have 2 by 6 as the chance of occurrence. Next I have what? E2. 2, 4, 5, 6. This is nothing but 4 by 6. It's 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. That is 4 by 6. That's the probability of occurrence of E2. When E1 occurs, bag 1 is chosen to draw the ball. When E2 occurs, bag 2 is chosen to draw the ball. Question is, find the probability of choosing a black ball. Suppose event A is that black ball is withdrawn. Now please try to understand the question. I have to find this. But there are two sources of occurrence of event A. If ball is drawn from the first bag, then the probability is going to be different. When the ball is drawn from the second bag, then the probability of occurrence of black ball would be different. Drawing a black ball can be from bag 1 or bag 2, and therefore by law of total probability, the moment there are 2 or more sources of occurrence of an event, you use total probability theorem. This is probability of, because there are E1 and E2 are the two sources. Why E1 and E2 I am saying? E1 says 1 or 3 turns up, but when 1 or 3 turns up, bag 1 is chosen. Bag 1 is one source of occurrence of event A, bag 2 is another source. But bag 1 occurs as a source when E1 occurs, and bag 2 occurs as a source when E2 event occurs. That means when E1 occurs, then B1 occurs. When E2 occurs, then B2 occurs. Fine. So E1 and E2 happen to be indirectly the two sources of occurrence of event A. So how do you apply the total probability theorem? Probability of first source multiplied by probability of occurrence of event A from the first source, plus probability of second source multiplied by probability of occurrence of event A from the second source. Probability of E1 is 2 by 6 multiplied by probability of occurrence of event A when event E1 has occurred. That means when 1 or 3 has turned up, what is the probability that ball drawn is a black ball? When 1 or 3 turns up, bag 1 is selected to draw the ball. That means it is being asked what is the probability of selecting a black ball or drawing a black ball from bag 1. In bag 1 there are 3 black balls out of 7 total balls. This probability is 3 by 7. Understood? 3 by 7 is the probability of drawing a black ball from bag 1, and bag 1 happens to be the source because E1 is occurring, plus probability of E2, E2 is 4 by 6 multiplied by probability of drawing a black ball when E2 event has occurred. When E2 occurs, then bag 2 is selected. So question is, find the probability of drawing a black ball from bag 2. Black balls are 4 in number, total are 7. So 4 by 7 is the probability of drawing a black ball from bag 2. This gives you what? This plus, fine, you have this as the required probability. Okay, this can give you 11 by 21. Cool, that is nothing but the application of total prob or probability theorem. Clear? Next question, let's see. An urn contains 4 white and 3 red balls. Find the probability distribution of the number of red balls in a random draw of 3 balls from the bag. Now this urn is containing 4 white and 3 red balls. Okay, so 4 white and 3 red balls. Red, red and red. I am saying find the probability distribution of, this already is giving me the definition of my random variable. I have to find probability distribution of capital X, where capital X is my random variable representing number of red balls drawn in the random draw of 3 balls. So capital X is the random variable which represents number of red balls drawn in 3 draws. When you draw 3 balls from this bag, either you can get no red ball, that means all balls are white, all 3 balls are white, or you can get 1 red ball, 2 white balls, or 2 red balls, 1 white ball, or all 3 red balls. So capital X can assume what all values? 0 red balls, 1 red ball, 2 red balls, or max 3 red balls. Fine. And therefore, what is the probability distribution of this? Let's find out the respective probabilities. Probability of no red ball occurring. No red ball. No red ball means all 3 are white balls. You've drawn 3 balls, all 3 are white. What is the probability that all 3 are white balls? Total number of ways in which 3 balls can be drawn from this urn of 7 balls is 7C3. And how many other ways in which 3 white balls will be drawn from this urn? There are 4 white balls, so 4C3. Fine. Next, probability of X equals 1. That means probability of 1 red ball, but 3 balls are being drawn. So if 1 red ball is there and 2 white balls, that means. And, please understand, and is going to emphasize upon the multiplication theorem, the fundamental theorem we've studied in permutations and combinations. So what is this? Total ways of selecting 3 balls out of this 7 available balls is 7C3. Probability that 1 red ball, now 1 red ball out of 3 red balls can be chosen in 3C1, and means multiplication. 2 white balls, we have 4 white balls in total, so this is 4C2. Cool. This is probability of 2 red balls and 1 white ball. What is this? 2 red balls out of 3 red balls and 1 white ball out of 4 white balls. In total, there are 7C3 ways to actually draw 3 balls out of the available 7 balls. This is probability of X equals to, what is this? All 3 are red balls. All 3 are red balls. Total ways of drawing 3 balls out of 7 balls is 7C3. How many are the ways in which you can draw 3 balls which are red out of the available 3 red balls? So you have 3 red balls, you can draw all 3 red balls in 3C3 ways. No white ball is occurring. That's the probability. Clear? Now it's very easy for you. You can write capital X and write Px 0, 1, 2, 3, and you can respectively compute these values 4C3 into or upon 7C3. What is 4C3? It is 4 factorial upon 3 factorial into 1 factorial. This is just 4 because 4C3 is same as 4C1, which is 4. So this happens to be 4 upon 7C3. This is 7 factorial upon 3 factorial into 4 factorial. This happens to give you 7 into 6 into 5 upon 6. This is 35. 35. So this gives you 4 by 35. Next you have 3C1 is 3. 4C2 is 4 factorial upon 2 factorial into 2 factorial. So it is 4 into 3 into 2 upon 4, that gives you 6. 6 into 3 is 18 upon 35. Then you have again 3C2 is what? 3 factorial upon 2 factorial. That means 3 factorial is what? 3 into 2 upon 2. 3C2 is 3 into 4 upon 35. This gives you 12 upon 35. And this gives you 1 upon 35. You can clearly see this is your probability distribution because 4 by 35 by 35 plus 12 by 35 plus 1 by 35 is 35 by 35 is 1. And therefore, this is your required probability distribution of capital X. Cool? Let's watch out for the next question. We have a random variable X has the following probability distribution. So the probability distribution is already given to you. Xi's and respective Pi's are known to you. The question is indirectly going to pose different types of unknown values. It says find the value of k in here, calculate the mean of this random variable and calculate the variance. Here, this happens to be your probability distribution of capital X. This can only happen to be my probability distribution when the sum of pi's is equal to 1. So if this is my probability distribution, clearly summation pi, I running from, how many values are there? 1, 2, 3, 4, 5, 6. So 1 to 6 is 1. That means minus or 0.1 plus k plus 0.2 plus 2k plus 0.3 plus k is 1. That gives you what? 0.3 plus 0.3 is 0.6 plus k plus 2k plus k is 4k is 1. This gives you 4k is 0.4. So k is 0.1. This is the value of k. Next it says calculate the mean. In order to calculate the mean, it's always advisable to draw your table of xi's, pi's and then respective pi xi. Xi's are what? Minus 2, minus 1, 0, 1, 2 and 3. I have pi's as what? 0.1. K is already computed to be 0.1, 0.2, 2 into k, that is again, this is what? 2 into k, this is 0.1 multiplied by 2, this gives you 0.2. Fine, then you have 0.3 and k is 0.1, so this is 0.1. Let's not multiply it here, this itself is 0.1 only. 0.1 into 2 is okay, 0.2. So I have 0.1, 0.1, 0.2, 0.2, 0.3, 0.1. This is pi. What is pi into xi? Minus 0.2, minus 0.1, this is 0, this is 0.2, this is 0.6 and this is 0.3. I am just multiplying pi's and respective xi's. What do you get this as the sum? 0.6 plus 0.2 is 0.8, 0.8 plus 0.3 is 1.1, 1.1 minus 0.1 is 1, 1 minus 0.2 is 0.8. So summation pi xi, I running from 1 to 6, this itself is my mean. And I have evaluated my mean as 0.8. Next is calculate the variance of x. If we have to calculate the variance, I should know that variance is nothing but what? What was my mean? Summation pi xi, I running from 1 to 6 and variance is given by summation pi xi square minus summation pi xi whole square. It is nothing but expectation of x square minus expectation of x whole square. Expectation of x is nothing but the mean. This itself is my expectation of x. So I just need to calculate summation pi xi square. For that I need a column of xi square. Pi column I already have. I will just respectively be multiplying and then correspondingly adding. Let's talk about xi squared column. This gives you 4, then 1, then 0, then 1, then 4 and then 9. So what will be pi xi square? Minus 2 into, no, this is pi xi square. So this is 0.4. 4 into 0.1 is 0.4. 0.1 into 1. 0.2 into 0. 0.2 into 1. 0.3 into 4 is 1.2. 0.1 into 9 is 0.9. Add this up. Whatever this comes out to be would be your, not the variance, but it would be your summation pi xi square I running from 1 to 6. Let's see. This is 0.5, 0.7. 0.7 plus 1.2, this gives you 1.9. 1.9 plus 0.9 gives you 2.8. 2.8 happens to be this value. And now what is my variance? It is this value 2.8 minus expectation of x, that is mean whole square. Mean is 0.8 whole square. This gives you 2.8 minus 0.64, which is 2.16. And that's how you evaluate each and everything being asked in the question. So guys, in here, the more you practice, the more accuracy you obtain, the more precision you have while the very computation of the solutions to the questions on probability. So my only advice to you is, please be very careful and accurate when you are trying to solve questions on probability. Practice more and more questions, and moreover, all the formulas should be at the tip of your fingers. You should be thoroughly crystal clear with each and every formula, and the more you practice, you would be able to decode what the question is trying to ask you, whether Bayes' theorem would be used or total probability theorem would be used. What should be my events? What should be the one sitting in the denominator? What should be the one sitting in the numerator? Which type of condition probability should be used to evaluate the result? All these things will be clear when you practice more and more questions. And last advice, whenever you are writing the questions down and solving them, don't skip steps. Please don't skip steps, okay? Small steps, if you skip, you try to assume more, in the end you get stuck, and when you go back to the question, you don't have that step written, and therefore you commit mistakes, okay? These are some bunch of advices which I would like to give you regarding probability. Practice more. That's it from my side. Thank you.